Hi everyone, and welcome to today's webinar. Today we're going to cover Sonobuoy, validating your Kubernetes configuration. With me today, I got John, who's the Sonobuoy tech lead here at VMware. So John will go over what Sonobuoy is, how it works, and how to get things running inside your own environment, what to look out for when it comes to the results, and how you can actually gather a ton of information using Sonobuoy. If you have any questions, you are free to raise your hand within the webinar here. So if you want to speak up, please raise your hand and I'll unmute you. If you would rather ask your questions in the text format, please use the Q&A button or the chat, and I will read them aloud. With that, John, take it away.
All right. Hi, everybody. As Jonas said, John Schnocky, the tech lead at Sonobuoy, and even prior to working on Sonobuoy directly, I was using it. So I feel like I've been with Sonobuoy for quite some time. My hope for today is that we cover a breadth of information, so you know a little bit about all the parts of Sonobuoy, but then also we're going to try and go a little more deep into a few sections, specifically what's inside the results tarball that you can use to diagnose problems, and also how you can build your own plugins to empower your own test flows. So we're going to start with an introduction about what Sonobuoy is, who would use it, and why, what really Sonobuoy accomplishes. And we're going to talk about conformance. It's always a key factor of when people think of Sonobuoy, what it's used for is getting those conformance results for their cluster. Then we're going to talk about the Sonobuoy structure, how it's laid out and how it works. And then we're going to do a couple demos each time, looking at a little bit something different. Then we're going to talk about the roadmap, the things we hope to improve over the next couple releases, and the things that we've recently marked off of our roadmap. So first, Sonobuoy is a diagnostic tool that makes it easier to understand the state of your cluster by running a set of plugins. This includes the Kubernetes conformance tests. It's customizable and extendable so that you can run it against any cluster and get the information that you need. So cluster operators, there's really two main reasons cluster operators would want to run this is, one, they've just stood up a new cluster and they want to make sure that it is in a good state before they start putting important workloads on it. So you might run an entire conformance suite just to verify the cluster is in the correct state and ready for production workloads. Secondly, if there starts to be problems, Sonobuoy is a way for you to run all those tests again and see exactly what is failing. Right? There may be specific functionality that is causing problems, and Sonobuoy can help you gather all that information as quickly as possible. Now, service providers as well would want to run Sonobuoy so that they can verify that a cluster with their services continues to function in a conformant way, in the proper way. And specifically, they'd want to know, does it pass conformance? Because when you can say that you passed the conformance test, you get a nice certified Kubernetes stamp like this from the CNCF. The CNCF develops a certified Kubernetes program to try and create the idea of what it means to be a conformant workload or a conformant cluster. And what that really means is it's promising that if your workload works on this cluster, then you move it to another cluster that is also conformant, it should still be able to work. Okay, that's important when you're moving workloads between clusters that may be in completely different environments. You still need to make sure that the basic workloads can rely on some sort of base level functionality that should work the same everywhere. Okay. It is important to note that certification to be certified Kubernetes is version specific because the tests that define conformance are constantly in the state of change. So as Kubernetes adds more and more features to alpha or beta or GA, right, they're going to rely on certain fundamental behavior that should be the same between all clusters. So Sonobuoy takes that hard part away from you as well, because we look at your cluster and run the appropriate set of tests for you to prove conformance. So let's talk a little bit more about how Sonobuoy relates to the upstream community Since we've talked about conformance, a lot of times people get confused about where those boundaries exist. And they are a little bit fuzzy, to be honest, because even though the CNCF is a standalone organization and there's the Kubernetes organization and code, and there's the Sonobuoy code, those seem like clear lines, but the developers do move back and forth. So for instance, the Cloud Native Computing Foundation defines what it means to be conformant. They're the ones that give that stamp of conformance for a certain version of Kubernetes. But they don't actually write the tests. They don't own the tests that define conformance. All the tests live in the actual Kubernetes repo. So as new versions come out, the tests keep getting put into that repo. Likewise, the Kubernetes repo and the test infra repo, they are the ones responsible for actually building the test image. That is bundling up all those tests with a few tools to run them. And that's published on every release. That is part of the upstream Kubernetes community. Now, Sonobuoy doesn't own those tests either, but we run them. So we define a plugin, which is really just a description of how we want to run those tests. So we define the plugin, and then we utilize that test image from the upstream community. And the CNCF points to Sonobuoy as a preferred method of running those tests so that everybody can have a simple way of gathering that data that they need and handing it off to the CNCF for review. But again, the developers kind of live in between all of these organizations. For instance, I'm the tech lead on Sonobuoy, but I'm part of a conformance working group in the Kubernetes community so that I do review tests that are being considered for all the way from the Sonobuoy side, all the way to the upstream side. And I help describe on the CNCF website how to run Sonobuoy for those results. So let's talk about the structure of Sonobuoy. It's at its heart a pretty simple application in that there's only 4 major components to consider. There's the CLI that's out here. That's the part that you actually interact with. And it produces a bunch of YAML that we throw into the cluster to actually run all the work. The main thing that it creates, the first thing to note, is the aggregator pod. Now, this aggregator is a Sonobuoy image. It's really just a minimal image with Sonobuoy, the CLI, put into it, and Sonobuoy is running in an aggregator mode. In this mode, it's looking at your configuration, and by that I mean the configuration of your test run. What plugins do you want to run? How do you want to run them? Those sort of things. And then for every plugin, it launches a pod that is a combination of 2 things. Your plugin, which is the thing that actually does the work, that runs the tests, that gathers the logs, and a Sonobuoy worker. Now, the Sonobuoy worker is responsible for the communication back to the aggregator. That communication is done over HTTPS, and Sonobuoy handles all of the secure communication itself for you. So the only thing that the plugin has to do is its own work and then transmit those results to the worker. And since it's local within the pod, that's usually a very simple thing. You can do a simple bash script is enough to communicate with the worker. Okay. The 2 plugins that we provide in Sonobuoy itself are the end-to-end tests. Those come from the Kubernetes repo again, but then also a systemd logs gatherer. And those kind of exemplify the 2 different types of plugins that exist. The end-to-end tests are what we call a job plugin. They run once in one pod and submit the results. There's the systemd logs gatherer, which is what we call a daemon set plugin. That runs once on every node in the cluster. So that can help you gather data about what resources and capabilities each machine might actually have, or gather those node-specific logs on every single node. You can probably find a lot more imaginative uses for that too if you just want to run something based on the number of nodes that you have. Okay? So those are the 2 ideas, that you run once or run once per node. Okay? So let's do a basic demo of some of the features of Sonobuoy. The main entry point or main command is Sonobuoy run. Once we do that, you can see it creates a bunch of objects. Like I said, it creates the YAML and throws that into your cluster to actually start the run. Now, by default, what Sonobuoy is going to do is run the end-to-end tests and run them specifically in a way that's going to test for conformance. So those test runs usually take about an hour. We're not going to wait for those to finish or anything in this demo. But then we also run the systemd logs gatherer so that you can see what's happening on each node if there are problems. Okay. Now, once the run is going, you have a couple of options about how to monitor that. You can do Sonobuoy status, which will list all the plugins that you're running and their current status, running or complete. And then it just says in a human readable fashion that it's still running, more or less be patient. You can also, if you want to dig more deeply into it, because like I said, the end-to-end tests take up to an hour to run usually. So maybe you want to know, how are those going? You know, are there failures yet? What current test is it on? Is it hanging? You can do Sonobuoy logs. Now, Sonobuoy logs is looking at the container logs for every container that we've launched in that namespace. So all of this is coming from the end-to-end tests. And you can use that to correlate with how many tests you're expecting to run. If we look up at the top, you can usually, let's do Sonobuoy logs. You can see and 4 out of the 3,000 tests. This is an important thing to point out as well, because like I said, there's the idea of conformance. That is a subset of all of those tests that exist upstream. So you only need to pass those 204 conformance tagged tests. The other ones deal with a lot of other upstream concerns, scalability, optional features, different storage providers, and things like that. So you may be interested in running some of those tests as well, and that's something Sonobuoy can help you do. But for conformance, those 200 are usually all you need. Okay. So let's clean that up. Another common command is Sonobuoy delete. And that's going to delete the resources that Sonobuoy created. Deletes the namespace, the pod, and the cluster information, or the cluster like role bindings and things like that. Now, if you're curious about what Sonobuoy is really doing under the hood, we're not trying to hide any of that. You can do Sonobuoy gen and actually see all of the YAML that we utilize. So you can see we've created a namespace, a service account for everything to use, cluster role bindings, so on and so forth. And you can even see the specific configurations that we use internally to describe your run. And all of these things are customizable by the user. So you can update the sorts of things that you're running for plugins, the sort of things that you're gathering after the plugins run for debugging purposes. And a very important part of this to understand is, here is all the stuff about your plugins. Okay? You don't have to give a full exhaustive description of an entire pod in order to run a test. You really just need a small section that's describing the plugin. So here's the end-to-end plugin, and it's a job. So we're going to run it once. And then there's some details about what image to run the command. All these sorts of container customizable options. But this is what's loaded by that aggregator pod. In order those plugin pods with a Sonobuoy sidecar. So let's go back to the presentation. Oh, I'm sorry. One more thing on here for basic functionality. I did want to show you some follow-up features. So I showed you how to do a run, but not what happens afterwards. So we didn't want to wait a full hour for a run, but there are some options such as quick mode. Quick mode is a useful feature. It is sort of like a smoke test of your cluster. It's going to run the end-to-end plugin still, but it's going to specifically set options so that it runs only one test that runs pretty quickly. And you can even specify Sorry about that. You can specify another flag, wait, so that this will block until everything is done. Now, this test usually only takes a few seconds, but then I'll show you how you can inspect the results. I promise I'm still here. Waiting. Okay. So now if we do Sonobuoy status, now you can see that this column has been filled. And not only is the plugin completed, we can actually see that it passed. And for a lot of users, like in their CI system, that might be all that you really need. But you can also, if you ask for the status in the JSON format, you can see additional information such as this passed one test and it skipped 3,584. And there's also some extra information about the results tarball. If you want to download it, here's things like its name and its SHA so that you can verify or store that metadata somewhere else. Sonobuoy status also mentioned that you can use retrieve to download that tarball. So the Sonobuoy retrieve command actually echoes the name of the file that it downloads. So I typically always store that in a variable so that I can immediately use it to check the results. There's this command, Sonobuoy results. This provides just a simple human readable report. Now here it looks pretty similar to just that JSON data, but if there were failures, as we'll see later, it provides additional functionality to dig deeper into those. And now locally, you do have a tarball that you can open up. And again, when we're taking a deep dive into those results, I'll show you what's all inside of that tarball. And we're gonna clean everything up for our next demo. So let's talk a little bit more about how the plugins work individually. At its heart, a plugin is really just a container that produces some output. The contract with Sonobuoy is very, very minimal, and it revolves just around this done file. Since the worker is launched as a sidecar, we add a mount that is shared between the plugin and the worker so that we can share data over just the local file system. So once the plugin produces some output, and it can be a single file, it can be a tarball, it could be a whole website, it could be anything you want to do. Maybe you're doing image processing tests or something like that. Whatever you produce, all you have to do is write the path to that object inside of this done file. And Sonobuoy is just polling, waiting for this file to exist. And then it reads it and finds out where your results are, goes and grabs them, and then sends those securely back to the aggregator. And if you saw, or if you remember, we looked at the results and they specifically said how many tests passed and failed. And that's because Sonobuoy is aware of some of the result formats that are common. Specifically right now, we are aware of JUnit. That's the most common because of the fact that the end-to-end plugin is the most common and it reports its results in JUnit. So once the plugin reports those results, the aggregator actually looks into them and actually counts up the successes, the failures, so that that Sonobuoy results command and the status can tell you more useful information, right? It's not just a black box anymore like it was a few releases ago. This is a relatively new feature. You can actually start seeing passes, failures, the names of the tests, and even the logs from the tests, all without even opening up that results tarball. And if it's not JUnit, we do also support just a very generic raw format. And that's helpful if you're gathering logs, producing JSON reports, whatever the case may be, we can still tally up all those results so that you can see how many documents you produced or dump them out without having to manually open up that tarball and navigate the results. So let's take a look at a custom plugin from start to finish. I'm going to talk about how you can build a plugin, run the plugin, and then view the results from that custom plugin. Now, inside the Heptio Sonobuoy repo, we do have an example plugin just called Command Runner, which is a very simple 3-file plugin. Right? One of these is even the README. So it is very simple. What it does is it takes all the arguments that the container has, and it runs them in the shell. Each command produces an output, which we store to a file, and then it reports all of those to Sonobuoy. The example code down here shows you from start to finish all the code that was required to go from this repo to actually running the plugin. So I want to show you each of those files, right? We need an image first and foremost if we're going to be running a Kubernetes container. So we build the image and we push the image to an accessible location. That Docker file can be very, very simple. In this particular case, we're starting from Debian. We're adding in some useful tools, right? If this is going to be running commands, I wanted it to have some tools in there. So like we have put kube control, we put curl and some net tools in there. And then we have one simple script. Okay? So get stuff in my container, run the work. Now that running script is very simple as well, right? This is all of my program logic, but really the key point that you should be aware of is this. This one function is what is satisfying the contract with Sonobuoy. This is what makes it really able to be run with Sonobuoy. And that is whenever you're done, it calls this function, it tars up a directory, and it writes the name of that tarball in a file called done. And that's it. Then Sonobuoy knows to grab that tarball and report it back to the aggregator. Everything else is bash specific about handling the arguments and running them, which is not important for this demo. So now we have an image and it's available for use, but we have to figure out how to tell Sonobuoy to run it. If you remember in that Sonobuoy gen output, there was a plugin definition of some sort that mentioned which image to run, how to run it, what are the environment variables, and that sort of thing. It used to be that you had to copy and paste that and edit it each time you wanted to make a plugin or write that boilerplate from scratch. That was confusing for most users. So we've added a Sonobuoy gen plugin command with just a couple flags, and it tells you which ones are required. You can create a plugin definition. So this produces all the YAML that's necessary to feed into Sonobuoy as a plugin. It is a job plugin. Here's the name. Here are some arguments. I want to use this image, which I've presumably published somewhere. And that's it, more or less. Okay. You don't have to worry about any other detail other than what image you want to run and how you want to run it. And so I've actually published the image somewhere, and I've saved that YAML to a file. So if I want to run it, this ran, if you recall, the end-to-end suite and in a full conformance mode, but you can specify which plugins with just the plugin flag. You can specify more than one plugin, that's fine. And if you want to specify the end-to-end plugin, you can do that too. But here, we've saved one, hello world.yaml. The flow for Sonobuoy is exactly the same, except now when it looks into your configuration, it's going to say you want to run this hello world plugin, and it's going to look up in a config map about what image to use, what commands to run. So we can see in this case, now my plugin has run, it's completed and passed, and we can look at the results if we want. But now instead of just running this basic Sonobuoy results command, we can still leverage that. All the functionality is the same, but we just have to specify that we're wanting the plugin hello world. And it has two, what it calls still tests, or two things that have passed. And if you recall, I said Sonobuoy is trying to be aware of the types of results you're processing. Here, that's just data. It's just output into a few different files. It's not JUnit. It's really not tests that pass or fail, but it's still useful because we can specify, or we can actually get that data out without opening up the tarball by using a detailed mode. Here, for every single one of those files of results that it found, it's going to print the file results with a prefix letting you know which file it's printing, right? And that's optional. You can remove that so that you can pipe it to other tools or save it to a file. But you can see we ran a command that said hello world, and we did another one that ran kube control cluster info from within the cluster. Okay. So this is powerful. You could do this to gather all sorts of other custom data or run your scripts. And if you did it as a daemon set, you'd run that on every node. Make sure that every node can reach the API server, or check what the network settings are on every node. You know, whatever your custom scripts of interest are. Now, this particular plugin had plenty of power behind it already, right? We just wanted to run a script. It didn't need any sort of privilege status. One thing that certain plugins run into is that they have a problem because they need to run in a special environment. They need to be in a secured or privileged security context, or they need to be in the host PID space. And that used to be a blocker for plugins, but we've recently added an ability to specify any pod options that you want. So if we do Sonobuoy gen plugin, like we had done before, but we add another option, show default pod spec. There's this new optional section of the plugin definition, which it will take all of these pod options for when it launches your container, right? We still need to put our Sonobuoy sidecar into the pod so that it reports the results. But all the other pod options that you need, you can specify here. So if you need to specify host PID, host IPC, or something else, right? All of that is available now to you, right? This can be very, very powerful. Also, if you need other containers, right? Maybe you don't have a single container test, but maybe you're running a database in one container and you know, another application logic specific thing in a container. You can add all of those there if you need. We're just going to add into that our sidecar worker, and you're still going to report results in the exact same way. Okay. Now, the demos that we have been doing so far, we're assuming everything went well, and I hope it does. It's really nice when everything goes well. But when you do have failures, you need to know how to dig deep into the logs of these runs to diagnose what those problems are. And Sonobuoy does a few things to help you, so I want to show you what those are. Okay. We're going to first identify failures, and then we're going to look through that tarball a little bit more to see what else can you discern about the cluster. And then specifically, because this is a very common question in our Slack channel, is what do we do at the end? How can we tie this back to the upstream code? Because oftentimes you do have to go all the way back to the code to diagnose the real cause of the problem. So let's take a look at how we can do that. So first, you can still use the Sonobuoy results command. And here I have a tarball from a failed run, just as an example. And you can see when you do have a failure, the basic behavior is just to list the names of the tests. Okay? This is useful so that you may even just know, since you launched your cluster, why that test failed, right? Maybe you were experimenting with a certain configuration object, and now that feature failed, right? That might be all the information you need. But if you need additional information, you can dig a little more deeply into it. Again, by using the detailed mode here, this is going to be running details for every test, right? So if you run this right now, it will actually run details for 3,000 tests, which if that's what you want, there you go. That's probably not going to be useful for you in this case. But the point is that since it's giving all that detailed information on every test, you can also pipe that to other tools like JQ so that you can filter for whatever it is you need, whether it's based on features or based on a tag of the test. Here, if we just want to see the ones that have a failed status, it's really just one test. This is a bunch of detailed information that Sonobuoy pulled from the logs for you. Well, this is one object. Here's the name. It failed, and this was the file. If you want to look at the XML, that's where we pulled all this information from. And it has a failure message and a captured system out. All this comes from the upstream, but because it was reported in JUnit format, it's able to integrate pretty seamlessly with Sonobuoy. Now you may just be able to look at this information and figure out why it failed. Personally, I usually open up the logs if I get to this point. So this gives us an opportunity to open up that tarball. When you open it up, you see data about your hosts, metadata about the run itself, information about the plugins, the pod logs, the resources, and even some basic data just about the API server itself. So we're going to go through a few of these. Not all of the data is going to be covered in this webinar, but hopefully enough to help you debug some of the most common types of problems that you run into. First, the place I always look is going to be in the plugins, right? There's folders for each of the plugins that you ran. We're digging into a failure for the E2E plugin. We're going to be looking at the global results, right? It was just run once, so they're considered global results. And here you can open up the logs. This is nice because you get all the colorization from your IDE. Looks a little bit nicer than just on the command prompt. But you can see in this particular case, it fails because I believe sudo was not found. Okay, so there's some sort of problem running this test in my environment, but you could tell by the name there were all sorts of feature tags, and it's no surprise to me that this test fails on my system. But if this doesn't work for you and you're still kind of scratching your head about why it might fail, you can try and correlate it with other things that are going on in the cluster at the same time. So like I said, we always gather the systemd logs. Right? Maybe there is just a systemic problem on your node. If you want to dig into those, here you go. This is what's actually happening in those systemd logs. If you still can't find the problem, I go to pod logs. Okay? After the run occurs, after all the plugins say they're done, Sonobuoy goes and does a number of other queries against the cluster that are only aimed to help you understand the results, right? So if you get a failure, you need to dig into it. Even if it's a transient problem, right? You can't afford to look into it later. You want to gather those logs now. You want to see what the state of the cluster was when that test failed. So by default, we always gather the pod logs for where we ran the tests. So this is the Heptio Sonobuoy namespace, but that's customizable. You can specify that you, for instance, want to grab all the kube system logs. That's another very useful one that you can do. And that's just part of setting configuration options when you do your Sonobuoy run. But this is useful because, for one, you can see the aggregator logs. This is useful because it's kind of the brain behind the whole Sonobuoy run. If there was a problem launching a plugin, you should see that message here, right? That's a common situation if there's a permission problem, right? Oftentimes, the credentials that you're using aren't powerful enough to do everything. Maybe it's doesn't have permission to create namespaces, or it doesn't have permission to create certain role bindings in the cluster. Oftentimes, you'll get that message here. If it does run everything, and this is not providing clues, you can dig into the logs of your job, right? We eventually cleaned up the run and the plugin, but we gathered all the logs before we did that. Okay? So here, this is just a text file of results. We already captured those in our plugin though. So this is not particularly useful in this case, right? Some plugins don't provide their logs as part of the results tarball though. So this can still be very, very vital. But you also get to see the container logs for the Sonobuoy worker. This is really useful if you're having a problem submitting the results back to the aggregator, right? Maybe there's some network problem and the connections keep getting reset. That would show up here. Another option for you to dig into is the resources. This is going to just be digging into all the JSON metadata that existed in etcd describing the objects in the cluster. So for instance, you can look at all the pods in the Heptio Sonobuoy namespace. There's a lot of information stored on these objects that can be useful in debugging. It can show you the exit statuses or the termination reasons for the different containers. And it can also just help validate that you ran what you thought you ran. So for instance, this was running my container and I can see the image here, but maybe I wasn't sure what image version I was using, right? I can check that here. In addition, I can check, well, what was that environment variable? Did I really run the test that I expected to run? So on and so forth. There's a lot of information here that can often point to the problem. Okay. But let's just, for sake of argument, say that still doesn't solve your problem. You're still having mysterious timeout or EOF error. Oftentimes you do get to that point where for the end-to-end test, you just have to go back to the upstream code. Now, when that happens, if you look in the logs, there's actually a lot of important information about what version of the tests are running, what version of the API server it's running up against. You can find those kind of sprinkled throughout, but this is usually where I grab them from. When it's running things, it will tell you full log lines about what file, what line, but it's important that you don't just go to the Kubernetes repo and go to this file and line. That won't be useful because, like I said, those tests are constantly in a state of flux. Lots of contributions, updating tests or adding new tests. So it's important that you do one of two things. You either go to this tag, so the v1.14.2 version of the test. You can even look, if you can find it, at the beta version, or you can look at this SHA. So for instance, if you go to the Kubernetes GitHub, the tags are available from right here. You just be sure to switch over to be looking for tags. Type in the one you want. Or if you want to get fancy, you can type in the SHA here, just in the URL as part of the path, right? Tree and then the short SHA will get you to where you want. Now, once you're there, you can plug in the full file name and path, or just navigate it through the GitHub API or web UI if you want. I would recommend, if you're at this point, that you clone the repo so that you can use your IDE and jump back and forth between functions a little more easily. But in this particular case, I was looking for line 347, and this is the thing that was failing. I can dig into each one of these things. How is it initializing the pod? Is that the problem? How is it reading the file? Is that the problem? Yeah. But that is really useful to go actually to the source, right? That's the one source of truth that has to work out and lead you to a deeper knowledge of the failure. Okay. So I want to talk a little bit about our roadmap. First, the things that we've recently knocked off of our bucket list, so to say. We've made it easier for you to run tests in your air-gapped environments. So if you weren't aware, to run the Kubernetes tests upstream or on your cluster, it's not just a single test image that's required, because those tests themselves are launching a lot of containers and pods and doing all sorts of things. So this command was made to help simplify and grab all those images you need. You could pull all the test images locally. You can push them to behind some sort of available registry so that even in your air-gapped environment, you can grab and run those tests. Then we've tried to make writing and using plugins more simple. You've seen how you can generate a plugin definition now from the CLI. You don't have to write that boilerplate code anymore. And then you run those plugins just from the command line. You don't have to edit YAML directly. In addition, we've made writing more powerful plugins possible. Prior to making the pod spec completely customizable, any feature that you wanted surfaced had to be wired through Sonobuoy entirely. So implementing host PID would have been one feature. Implementing host IPC would have been a separate. Every single pod field would have been a new feature, a new PR, a new option. But in one fell swoop, all those options are now available to you. So you can run plugins in exactly the environment you want. Then we've tried to make reporting the results for even custom plugins simplified by the Sonobuoy results command. Again, I really want to emphasize that this is extensible. This is a brand new feature. So we currently only process JUnit, but there's no reason it can't be extended to understand other testing frameworks or types of output. In the next couple releases, we plan on continuing to work on the plugin opportunities and uses, whether that's making things more powerful or even just creating plugins that fill a need in the community. And an upstream ongoing issue is trying to be able to run these end-to-end tests in even tainted environments. There's a lot of custom production environments where the end-to-end tests just simply won't run because of assumptions the framework is making. And we're trying to work with the upstream community to simplify and streamline that process. And then a very requested feature are status updates. The end-to-end tests in particular can run for hours at a time, and so might your custom plugins. We want a way for, through the CLI, you to see the progress, how many tests are completed. Right? If you see that you're taking 10 minutes per test, there's probably some timeout issue and you're not making the progress that you think. And there's no point in waiting 3 and 4 hours to get those results. So that's going to be very useful when that's implemented, probably around the time for v17. So that corresponds to Kubernetes v1.17. And after that, our priorities in the future gets a little more fuzzy, but we do know that we're looking at supporting Windows nodes and running tests on those. This is a big thing the upstream community is working on in Kubernetes, getting all the conformance tests to support different types of nodes and have a Windows parallel. And they're trying to work out what conformance means on those. Likewise, we will have lots of work to support those Windows nodes. So you can definitely pitch in and help, whether it's lots of small bug fixes or helping us figure out what and how to run the tests for all these Windows related workflows. Then again, the plugins, we're looking at seeing what need the communities really have, whether it's creating new plugins, publishing those plugins, if there's different ways so that you can have your plugins work together in a more powerful way. We want to see what you're doing and how we can help. If you need to reach out to us, whether it's questions about Sonobuoy itself or issues, right? We're always available on Slack in the Sonobuoy channel. And then of course our GitHub repo, if you want to clone or fork or submit a PR. You can follow us on Twitter. We often release information on our upcoming features and releases. And our brand new website that features all our documentation as well as blog posts that kind of walk through the new features as we introduce them. So again, Sonobuoy doesn't own all those upstream parts, whether you have a question about conformance or tests. We don't own those, but we're happy to help. A lot of people that work on Sonobuoy or use Sonobuoy, we're all working in the same area, right? We're trying to run the tests, often the conformance tests, often for the goals of getting CNCF conformance. So whatever your question is, hopefully we can help and we'll see you there. Thank you.
Awesome. Thank you so much, John. I do have one question for you here regarding Sonobuoy, and if I wanted to get started with Sonobuoy, could I run this against a kind environment?
Excellent question. So can you run Sonobuoy against a kind environment? You absolutely can. And that's actually what all these test results that I was doing for my demo are from. So I have a, I get clusters. I have a single node cluster right now running. And that's how I run conformance tests. I don't think a single node cluster will not pass conformance, but that's not kind's fault. To be conformant, you do need 2 nodes. But if you just want to tinker with Sonobuoy or run your own custom plugins or run a specific test, yes, often kind does exactly what you need.
Awesome, thank you. Are there any other questions from the community members on the call here? All right, I don't see anything here. I want to thank you all. Thank you so much, John, for doing this presentation. And I want to thank you all for joining today. Please join us on Slack and say hi. We will be uploading this recording. If you missed anything, we'll be uploading it to YouTube shortly. And with that, thank you all so much for joining today and have a great rest of your week.
Thank you, Jonas.